Kick things off. We're recording. Um, Today we have an interview with David Hoglund. David is the founder and CEO for Integra Systems and has been involved in healthcare and wireless for, I don't know, over 20 years, certainly,
Yeah.
and been involved on the medical device side as well as the wireless infrastructure and wireless device side. So he's sat on both sides of the table and has a great perspective and some unique skills in the industry, actually, that we'll talk about as well. So before we get started, I'd like to find out. Oh, here we go. We got some people talking about where they're located. Here we've got somebody in Brazil. Where else is everybody located? I saw somebody on the list that I know is in New York City. Um, we're in. I'm in Beaverton, Oregon, and Dave, you're in.
I'm northwest of Philadelphia, about 50 miles south of.
Wow, London, Dallas, Sacramento. Good geographical distribution. Indianapolis. That's a great city. Have you been to Basbo's Pizza lately, Kevin? Brantford, beautiful place. Hi, Rich. Um, so as we go, feel free to ask questions. We will grab the questions and address most of those at the end. And so also there'll be a recording um, of the interview at the end, so that you can go back and peruse it for picking out specific tidbits of information that you might be looking for. So I guess I will kick off with the first question, and that is, what's the difference between consumer versus enterprise wireless devices? And let me give that a little context. Before we started, some of you early arrivers listened to us talking about the mobile handsets that people use in hospitals and other healthcare provider organizations, and sort of the tension between, or the choices really between a consumer type product like the iPhone and an enterprise type product, of which there's several. And so the question, Dave, is what are the differences between those, and why do people pick one over the other, and um, are there meaningful differences between them?
Tim, I come from a perspective as I worked for about 20 years ago. I worked for Symbol Technologies, and they were kind of the leader in barcode scanning and mobile computing, and kind of gave me an indoctrination to like, well, what do you really need for an enterprise device? I think when the iPhone came out and Google type phones came out, the traction was the user interface, and people really adopted that, really wanted that. The challenge has become, first of all, the roaming capabilities of the radio, the wireless LAN radio, also the need for hot swappable batteries, replaceable batteries that you can change on the fly, and also the ruggedness of the device. In other words, can it withstand drops on concrete repeatedly? So, so if you go back to the radio side, you got it. The radio that was put in all these consumer devices from the wireless LAN perspective was pretty much an afterthought. The idea would be to connect to a Starbucks or your home environment, but the challenge became when you needed to use it in an enterprise environment to maintain that secure connection with these certificates, and then also to maintain that while you're roaming from AP to AP without dropping the connections. And a low cost radios kind of failed in that perspective. The second piece would be if I'm using that consumer device and now I'm going down to 20% power, a lot of the new devices, you can't replace the batteries. So what do you do? So what's happened is you've had to use sleds that go on that device to provide extra power. So you actually got to charge and maintain two different batteries. So and then if you drop the device, if it breaks the screen, then you have that problem. So really trying to take a consumer device and make it used in an enterprise environment is just hasn't worked.
Um, what kind of use cases do you see roaming as an issue? Obviously, voice. If they're using the handset with a messaging vendor who includes wireless voice over IP, and they're doing a voice call through the messaging app, roaming would be important there if they're walking and talking, which a lot of people in healthcare do. Um, are there other use cases that come to mind where roaming would really be critical?
You made the same with the voice over IP. So for voice over IP, you need your wireless network design with a neg 65 dBm minimum signal strength and with a co-channel interference of less than 2%. So that's the basic design of the wireless LAN network. Now, what's happened with the consumer device is that radio uh, may not have enough power or the ability to connect and pass a nice handoff when you're roaming. So as you're moving from AP to AP and maintain that secure connection, what happens is that connection may just drop. Now, some enterprise customers say, well, we can make up having a stronger environment by putting more access points within that environment to make up for that radio that's not as good as what it should be. Now, when you put more APs in an environment, you actually raise the noise floor to create more co-channel interference. So it's a self-defeating prophecy. So it really comes down to the basic tenet of that consumer device is designed to provide cellular connectivity, provide user interface, and the wireless LAN side was, they put in a very low cost radio.
Okay. Well, from time to time, I keep hearing about how, cellular is going to take over Wi-Fi networks, and that hospitals in the future will use the cellular network rather than their own Wi-Fi network, and just, I don't know, pay for minutes on the carrier's network. Um, what is the role of cellular in healthcare, and both in the enterprise and out? And how does that conflict or compete with Wi-Fi, or is that do they complement one another? What's
I
the
think there are two models that complement each other. First of all, wireless LAN, all the medical devices and EMR. That's I would consider that more of an internal type network that's needed. Both are needed. I would say the hospitals of today need pervasive wireless LAN coverage, like electricity in your building everywhere. But also now, because physicians and patients' families are using their phones, they want that connectivity outside, all the time. So, I had an experience where had a family member in surgery, and for me to use my phone, I had to go outside, literally in the rain, uh, to make the call. So it comes down to today's working environment. Everybody's carrying their phones. They're all communicating. So I see hospitals want to provide that as a necessary convenience. So in other words, I have to have this for my consumer, which is the patients and the families and physicians. But I also have to have wireless LAN because I have to connect all my infusion pumps, the EMR, patient monitoring, voice over IP.
What's the role of a distributed antenna system with both Wi-Fi and cellular?
Well, distributed antenna system, or DAS, as we know, is essentially an ability to bring the signal from the outside into a building if you don't have that adequate coverage. And that could be a microcell, it could be a coaxial antenna system, whatever. But the model, say 15 years ago, or 10 years ago, where the carriers used to look at what they call average ARPU, average revenue per unit. So when people were being given Blackberries, they would say, all right, well, I can fund the DAS system, and I can put that inside a large venue, like say a sports arena or something like that, but maybe not just a single hospital. So now the model is basically kind of moving toward, as an enterprise customer, I need to provide that for my customers. In case of hospital, my customers are the patients and the families and the physicians, because they demand that phone works. So I see the business model as People are saying, well, we'll pay for that ourselves. We'll work with the carriers. We have to have it multi-carrier. You have to have AT&T and Verizon. There's also the need in a lot of these go over 200,000 square feet or even over 2 or 3 stories. Now, for public safety, a lot of
Mhm, mhm.
enterprises are saying, look, in order for you to get a check off that you can actually own or occupy the building, you have to provide public safety coverage.
And
So
that's the public safety coverage is what and what frequencies?
for first responders, it
Okay.
would be, in other words, where this all happened was after 9/11, where people couldn't use their phones going up in buildings. They didn't work. So now there's been laws that have come out and said, look, if we have a certain height of the building, certain square footage of the building, as we build that, then in order for you to own or occupy that, the fire marshal has to go in there and validate that you have public safety coverage. So really the DAS is now converging to provide public safety coverage, multi-carrier coverage, because everybody's using BYOD. They're bringing in their own phones and they're not going to be limited where it used to be where Verizon or AT&T said, well, I'll just put in our own system. Well, now it has to handle basically all the carriers as well.
Right, right. I keep hearing about 5G is the next carrier, the next cellular technology, and how it's going to change the world. Is it really?
Well, it goes back to what is good enough. So if we look at wireless LAN, you have 802.11n, and now you have 802.11ac. How many people need the speed of AC? Some people may want it for video, but in the case of the carrier side, what's happened is where people are changing out their smartphones like every year. Now the cost of the phones are going to 4, 5, 6, 700 bucks. And then how do you really need to change your phone every single year? And what I mean by that is your phone right now is 4G. So there's two things have to happen. The phones that are coming out have to have the 5G chipsets put into them. And then the carriers have to have support that as well. And that's not something that you're going to flip the switch overnight. So I think the challenge for the Apple and the people provide, Samsung and LG, the phones where the people are replacing them every single year, is 4G good enough for most people? Do I need a gigabit speed on my phone? Maybe, maybe not. But I also see where it's happened too is you have the IoT model. So now you get the ability to, there's new business models where you can take devices and instead of using a VPN in a hospital, have to get it on network, you can use an IoT router that can go up to will go up to 5G, so you can do remote software upgrades. So I think that's a big model going on. And then you also have police cars and ambulances now being kind of mobile hotspots with 4G, 5G out, and then creating a wireless network around that vehicle. So I think
Mhm.
that's the drive there for 5G too.
Okay, that makes sense. When it comes to wireless medical devices, uh, why, and you want to connect, you want to add connectivity to a medical device, there's two basic options. One is Ethernet and the other is wireless. And why is there a preference? Is there a reason to go one rather than the other? Um, and if so, what are those reasons?
Well, if you look at that, why Wi-Fi actually took off, and I actually worked for the founding member of the Wi-Fi Alliance in 1999. 802.11 was around both FH and DS for a number of years. What really was a cross the chasm moment was when 802.11b got approved in 1999, which gave you up to speeds of around 10 to 11 megabits per second, which was around the speed of Ethernet at that time. And then now what's happened is that was 18 years ago. So now you have N and AC, which huge amounts of speeds. And now you also have the cost model going down. So where you used to have a Type 2 card that cost 200 or 300 bucks, you get a wireless LAN chipset for less than $1. So does it really make any sense to wire the hospital with Ethernet with jacks every room for the cost to do that? Or is it better just to provide that mobile connectivity? Um, I was consulting for a company last month, and there was an intern that was starting an electrical engineering student, and they gave him a laptop and they gave him a patch cable. And the guy said, "What's this?" He didn't even know what it was because the new generation, all they know is wireless.
Well, certainly I've seen in my practice that wireless from a usability standpoint is much is much more effective from a workflow standpoint because it's automatic. You don't have to think about it. You don't have to remember to plug it in, and you don't have to remember to unplug it when you're done and wheel that device away and accidentally rip out a wall plate or something
I
like
also
that.
think from a security standpoint, so your traditional model was to provide RJ45 jacks in, say every other room or whatever. So now you have to maintain those ports. So if you're not occupying that area, are you maintaining your from a standpoint of IT infrastructure, are actually turning off those ports, or do they become a vector for you to enter into the network? Um, Years ago, when I worked at this company, I could take a wireless access point with a patch cable, plug it into a port that was not turned off, and that automatically gave me a backdoor into the network. So from a security standpoint, I think the wireless aspect is much easier to maintain.
Let's talk a little bit about testing requirements for wireless medical devices. Um, the vast majority of the radios, certainly all the radios that a manufacturer would contemplate putting in a medical device, have FCC certification and have been tested. Um, but when you put a radio in a medical device, there's extra requirements. What are those requirements?
Well, there's what I consider like two buckets. First of all, you have to validate and verify how that application will actually work in a mixed ecosystem environment. And what I mean by mixed ecosystem is that in a hospital, you're going to have laptops and cards, VoIP, video, may have infusion pumps, and they have maybe patient monitoring. And so you have to really validate and verify in a high intense roaming environment with maintaining that secure connection through passing all security certificates with all that traffic. Will that application perform correctly? So that's one area that, because what's happened is a lot of device companies, when they build something, they'll do a limited testing within their own environment of passing data, but that's not a true ecosystem test of traffic, latency, roaming, and security. So that's one aspect that needs to be tested and validated. Now, even though that radio has had EMI and EMC testing to get the FCC ID, which you have to have put on the back of their product, the regulatory bodies, including the FDA, have said, well, we need to validate and verify what we call wireless coexistence testing. And that's simply taking it a step further and saying, will your device work in an intense environment with other wireless emitters, such as electrosurgical units, such as two-way radios, such as microwave ovens, Bluetooth, whatever that may be, and will that traffic and connection be maintained? Then additionally, will your radio or your device cause problems with other devices? And that's somewhat of a checkoff box. And that primarily came out of the days of medical telemetry in the late 1990s when digital television blew off 200 channels of medical telemetry. And everything before that time was essentially controlled and licensed. And Wi-Fi, when it came out, it's like the wild, wild west. It was unlicensed. So the FDA started saying, well, how could we look at providing additional protection, suggestions, what we should be doing? And that's become primarily a checkoff box for every new product that comes out, with whether it's Bluetooth Low Energy, whether it's GSM, whether it's Wi-Fi, whatever wireless emitter you put in that device, you'll have to go through that.
Can you give us a brief outline of how you go about testing these devices, your services that you offer?
Well, on the validation verification, I've been a very big proponent of, if I go back to say 10 years ago, where I had to do this for one patient monitoring company, I had to physically take 10 or 12 monitors, put them on simulators, put them on a little cart, move them all around to kind of simulate
Mhm.
um, network traffic, which that's not the best way to do it. Then a company called Bearwave came out, which is now part of Ixia, and they actually have the ability to do true ecosystem testing. So I use their services combined with my test plans to validate different uh, levels of traffic and model voice, video, data, patient monitoring traffic, fusion traffic, and be able to simulate 100, 200, 300 connections and do that on various load conditions of roaming and all the different security supplicants known to man that you
Mhm.
come across. And also using enterprise gear from the top manufacturers versus using something you buy from, a large retail client or customer. So that's one aspect. The other one's coexistence testing, as I mentioned. So I'll actually um, have a highly sophisticated piece of equipment. We'll all measure within a uh, validate verified environments. This is a hospital or OR room. Take baseline measurements, and I'll take a various wireless emitters, and I'll introduce those wireless emitters at different distances and different frequencies and different power settings. And I'll take spectral shots of those. I'll take photographs of everything, and I'll also run network traffic between those two devices to show that in the presence of all these wireless emitters, nothing affected the network traffic, nothing affected the application. So I'll write the test plans, I'll do the testing, and do the write-ups. It'll be about a 90-page output document that they'll be able to submit with their proposal that will be essentially a check-off box for the reviewer.
Now, it's my understanding.
I know I've done that for, I guess, 12 different companies with all different types of products from Bluetooth to wireless LAN to GSM, you name it.
Now, it's my understanding that this is the kind of testing FDA requires for um, wireless medical devices, this is not just some nice to have kind of thing.
You're correct, and part of the challenge is the pushback. So, well, we already got an FCC ID on it, and they've had to do the EMC and EMI testing. And I agree. For you to get the FCC ID, you need to do that. But what this is demonstrating is, okay, your device is going to be used in OR setting. Have you taken your device and put it in OR setting with all these different wireless emitters that could be used, including ESU, and does it work as advertised? And that's what they want to see.
Right, right. Objective evidence.
Objective evidence, correct.
Yep. So if you're going to enable a medical device, there's a variety of technologies that can be used. What are the best technologies to use for that?
That's a good question. It depends. I worked with one company that wanted to have connectivity in a home environment. So we ended up using a GSM radio, and that time we used Zigbee. But now, what's really happened is you have all the module manufacturers, SoC systems on chip. Now the module manufacturers have a combination of 802.11 and AC, and also low power Bluetooth. So low power Bluetooth uh, really didn't take off. You had Bluetooth in mice and keyboards, but where it really took off was the advent of the smartphone. So it's kind of displaced all those other personal area technologies such as ANT and such as Zigbee and such as Z-Wave. And so now people are saying they're building apps that go on the phone that want the devices to connect to the phone. And you may not need bandwidth of wireless LAN, where it might be just good enough to do a peer-to-peer between the phone and that device. Or I'm actually working with one company that's building a surgical device that connects to a tablet. And you could also think about using that phone as a backhaul to LTE. So it could go peer to peer the information could go to the cloud. So it all depends the use model. If it's going to be, now that we see we want more connectivity in the home, it used to be when they sent the patients home, if something happened and you came back in the system, the healthcare just system pay for it. So now there's a model where people want to make sure that when I send a patient home, are they adhering to certain programs? Are they doing certain things? If they're using a piece of equipment, can I connect that they're actually adhering to using that equipment? So now with low power Bluetooth, the smartphone, wireless LAN, combining low power Bluetooth, and now you have LTE and GSM IoT type devices. There's a whole huge landscape of opportunity to build products with multi connectivity.
Excellent. I remember, gosh, almost 15 years ago, I was the product manager for a project to develop a component radio for a medical device. Do manufacturers still think that developing their own component radios out of chips is the way to go, or are people buying off the shelf radios? And if so, just what kind of radio? Just a cheap radio that you put in a laptop, or a different kind of radio?
Well, I've seen my share of what I call train wrecks. Um, if you go back to how that has to work, the healthcare or hospital environment and the use model is one of the most intense wireless use models. No, I
Yep.
mean, so with that being stated, you have to have a quality radio SoC that actually just works and works very well under a lot of stress with roaming and all the different security supplicants, etc. So some companies have gone out there initially said, well, I'll buy they're all the same. Wireless is wireless, 802.11 is 802.11. I'll just go buy an SoC and I'll try to build my software stacks and do it all internal. And that's not a very wise idea.
Mhm.
Expertise is an internal, and then that also has to be kept up all the time. So
It's harder than it looks.
harder than it looks. So the shift is, I always suggest let's look at a module manufacturer that's taken the SoC, that built their own security supplicants on top of that. The roaming algorithms are very solid. They've got, not that I believe in Wi-Fi Alliance approval, but they've gotten that. They maybe gotten Cisco CCX approvals. And more so, they've gotten all the FCC and global approvals for that module. So if I want to go, if I want to go build a device, I already have a predicate FCC ID that I could use to easily get an FCC ID on my device. If I want to go sell that in Europe, it already has CE markings. If I want to go sell that in New Zealand or Australia, the radio's already been approved there.
Mhm.
So those are the hidden things that become very, very difficult things. People aren't looking at that. So to go back to your statement is that, I've seen people go down and try to do this all themselves and go buy an SoC for somebody, and it turns out to the project is delayed for years, or it gets to market and it doesn't work.
Right.
So they get it to market and they find out, well, I'm in a mobile environment and I'm constantly dropping connections, so they can't fix that. So they have to go back and spend millions of dollars to redoing the entire product.
Mhm.
So those are the things that I've seen. So that basically, I try to tell people, here's the heavy lifting here. Here's the reality where things are, and there's a cost and time to market, and additionally, who's going to be responsible for maintaining all the different security changes and all the changes going at IEEE, and who's going to be responsible for validating and verifying that, and all the different manufacturers' infrastructure, because this is a constantly moving target.
Right. And how often does Cisco come up with firmware upgrades for their Wi-Fi access points and controllers?
Well, at least yearly. So I mean, if you look at
Yeah,
look at a medical device product, people aren't thinking about constantly. I mean, that's another thing is that then as a device company, in reality, you're going to have to be responsible for validating, verifying those changes in the enterprise infrastructure's equipment and the wireless LAN controllers as well as the access points. So it's just not a one-time thing. So
no.
that adds. So when you look at designing the client side, the initial testing, the ongoing testing that's required, it's no small task.
Yeah, I've seen situations where the hospital installs uh, a new firmware upgrade for their access point controllers, and they turn it on in a unit with Wi-Fi medical devices, and boom, it knocks all the medical devices off the network. And when those medical devices are patient monitors, and all of a sudden you lose patient monitoring, that's problematic. And it was a real challenge for them because they had to roll back that upgrade just to be able to get everybody live again.
Well, I
Uh,
think there should be one of the things I've advocated with one company is there needs to be agreements in place between the hospital and the medical device company. So if I, as a device company, if I validated and verified on this Cisco version of firmware and software, and that's what you're going to be installing on, then there needs to be sign-off documentation that before you go off and um, change anything, you notify that company because it's otherwise it gets into this left hand's looking at the right hand and it's not a good situation.
right, right.
And conversely, if Cisco or Aruba or HP Aruba comes out with a new flavor, a version of firmware and software and the wireless LAN controllers and also APs, then as a device company, I would feel obligated that I need to test and validate that, not for any FDA approval or whatever, but basically validate and verify how that works and have letter to file internal to my own company because that's best practices. That shows that hey, they've moved forward, they've come out with this as a company. We have validated and verified that no, it all works as it should be working,
Hmm.
and I think that's something that again that adds when you talk about trying to design your own stuff up front. Why not spend the resources that you're going to have to spend in the testing on the back end? Um, Let somebody else design the module. They know it works. Let them be responsible for all the software upgrades and supplicants and changes, and push that risk back off on them.
Hmm. Um, the the packaging for these component radios that you can get from third parties that are intended for wirelessly enabling embedded system devices. The packaging standards have evolved over time. What are people doing now?
Um, Basically, there's different types of interfaces. Some of them use SDIO. Some of them use the USB. Um, a lot of it all depends on the design of that product itself. If it's what's a footprint, then
Right.
if you need a onboard antenna, a chip antenna, um, or if you'd be better using uh, a patch antenna, you know, put in, we're going to give it better RF coverage. Um, that all depends too. So I ran in one instance where the radio and electronics have to be used in the actual device has to be put into a steam autoclave. So that required packaging of the electronics in the module within a glass, originally was Clovar glass, but glass ceramic housing and laser welded with pinouts to protect it.
Wow.
So,
Sounds expensive.
well, if you take that, take a stereo and put it into a convection oven or an autoclave, it's not going to come out very good. So,
No.
So, so that became an instance of packaging of how you had to have the feed throughs from that housing come back out, and those feed throughs also have to be protected. Then the patch antenna that came out had to be protected as well.
So what are the top three mistakes that you see manufacturers make when it comes to adding wireless to their medical devices?
Well, I think we touched on that earlier. I think trying to do it all themselves and trying to think I can go off and buy an SoC, an 802.11 chipset, and then purchasing gets involved, and they want the lowest cost, and no one's validated and verified how that will actually work in a high intense roaming situation, security situation. They just go off and build a product. That's that's one thing that I see. The other thing is they haven't sat back and said, well, have we defined our application requirements on how that works? They'll just go off and get a radio and start going down the road. Second is when they start building a product, rather than when they get finished, they should do the upfront testing of the product to validate and verify that those specifications are what they are. Because a lot of these companies, some companies that publish the specifications, how do you know they're correct? You don't. So you have to do your own internal testing, because if they go back to that device, if it's a patient monitoring device, it just has to work. So I think doing all that upfront testing will save a lot of headaches down the road. And then the second piece would be, well, now when I want to go deploy that into an environment, who is doing what here? Have I validated and verified that the coverage requirements, the signal strength requirements, the software firmware, and the infrastructure has all been validated and verified? And then what checkoff documentation do you have between the company deploying that and the end user, the healthcare user itself, versus just going to deploy it and saying hands off and whatever, and then just like you stated, if somebody comes and decides to change the firmware and software, and no one's telling anybody about this, and then something doesn't work. And that could be, if when it says something doesn't work, that could be what happens if an alarm doesn't get through to the central station and there's an adverse event.
Yep.
Whose responsibility is that? That makes sense?
Absolutely, absolutely. Yeah, I've seen there's a lot of impacts on the business delivery system of a medical device manufacturer when they go wireless or just adopt connectivity in general. Uh, Testing is a huge part of that. The Another part is feasibility work and doing the feasibility work up front, like the testing that you mentioned, um, playing with some radios and figuring out what kind of specifications do they really need for a radio to get the kind of roaming and the kind of rapid network connection speeds that their application needs and all those kinds of things. Um, and most medical device manufacturers, for their traditional embedded system product, tend not to do a lot of feasibility work. You know,
I
they're
mean, I worked with one company that they said, well, we don't need to do any testing. A radio is a radio is a radio. Well, the product dropped connections all the time. They actually had an FDA recall, recalled the product, cost them millions of dollars to redo it. The other one decided, well, we need to do this testing, the validation, verification, as I mentioned, as well as coexistence testing for the FDA approval. So we did the validation, verification, ecosystem testing. They're going, wow, we didn't know about this. And they actually were able to get the data where they could actually tweak their algorithms to make it work the way it should be working. But they
right.
didn't have that expertise or equipment internally. So I think going forward, manufacturers should potentially look at it's probably more cost effective for them to outsource this and say, all right, well, we're at this stage, let's validate and verify. Um, if we have a change in the enterprise infrastructure from Cisco Aruba, well, we need to test on that also. So I think the mindset has to be from the device companies that this is not just a one-time thing. This level of testing and checks and balances has to occur through the entire life of the product. And,
Yes.
and that and that's a different mindset before Wi-Fi came out, because people would, medical telemetry, WMTS was all just licensed. So we built a product. It didn't have wireless in it. It's a 6 or 9 years period of time that's out there in the market. Yeah, there's some software changes, whatever, but now it's you're working you having to have a controlled device in an uncontrolled environment that you have to continually validate and verify. And that's for risk management. And that's because the product is what it is.
Yep.
Yep.
So
So
let's
let's
look at the
look at the
same
same
thing
thing
from the
from the
perspective
perspective
of
of
providers. What are the top three mistakes you see providers make when it comes to wireless medical devices and in wireless in general?
Well, I think if you look at the early days of Wi-Fi deployments, they were, traditionally laptops and carts, and the carts were taken into the rooms occasionally. Maybe you had voice over IP that you needed neg 65, instead of getting neg 85 dBm, you need neg 65 dBm and a CCI less than 2%. So you need to do your site design differently. But now, if you're looking at patient monitoring and infusion pumps, those devices are used in the rooms.
Mhm.
And the patients are going down the hallway, down the elevator, into radiology. So if the patient's wearing an 802.11 telemetry, they're laying on their side in the bed, then that signal has to go through the patient's body, or it has to get through sometimes a bathroom that's with um, tile and metal to an access point that's in the hallway. So did the provider do a site design, or did the clinical people sit down with the IT organization and say, look, my patient is not only going to go in the step down area, they're going to go down this hallway, they're going to go down the elevator, they're going to go down to radiology. I need to have coverage in all those areas. And did the site design for wireless LAN, did it take into account that at the edge of that room by that window, I need a neg 65 dBm signal strength, not just out in the hallway?
Mhm.
So I think those are the challenges for the providers. At the early days, the site surveys were designed for limited coverage in the hallways and areas, but then weren't necessarily designed with sitting down. I mean, I did basic things years ago where I got architectural plans and I sat down with the director of nursing and the IT organization. I handed the nurse a highlighter and said, all right, highlight where your patient's going to go. And they had them initial off each page. And then, all right, well, this is what your design has to be, because you know that the clinical requirements have to be communicated to the IT organization, and then there needs to be validation, verification that that remediation was done before the device company goes and deploys.
I've constantly been amazed over the years of stories where a hospital will design their Wi-Fi network, get it installed and working, and then they'll just add an application and not do anything, just see if it works. And even the network VAR that installs and maintains their network doesn't require or insist or recommend that they do the site survey. And then when they add this new application to their network, and it doesn't perform adequately, then they finally say, "Oh, okay, well, we'll do a site survey and we'll redesign the network." And they could have skipped all that and just done the site survey from the beginning. Uh,
I was called in to work with the Department of Defense organization. Um, I can't name, but anyway, I was asked to come in and evaluate the existing design of the wireless network, which ended up being a joke. But I was able to get the floor plans and designed with predictive modeling using software with about a 95% accuracy of where actually that AP needed to go by knowing the attenuations of all the building materials, the doors, the attenuation of the doors. I was able to build that into a scientific model. They actually gave that back out and said, well, this is how you need to install, and then walked in for one day and validated that installation. So the days of the walk around site survey and spending all that time in doing that aren't necessarily needed today, but the clinical requirements have to be communicated to the technology provider that it has to be designed this way. Because a lot of that just is it just there's disconnects there is what I'm trying to say. So
Yep. Yep.
oftentimes.
Absolutely. So let's shift gears here. I'm seeing some questions here in the chat window, and so we'll go up to the top. Hey, you guys come up with more questions, just type them into the chat window. Here's someone that says they have a wireless handheld ultrasound device, and they're interested in the HIPAA encryption requirements over Wi-Fi. You want to take that, or shall I?
Well, I mean, first of all, there's two pieces to this. It's what information are you sending, sending out? Is it patient ID information? The second piece would be if you mention encryption or security certificates. It's a matter of complying. There's not just one standard that people are using out there. In other words, every hospital is not the same. So I would say you have to test against all the different, WPA2 enterprise, WPA2 enterprise, dot, 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 and passing all the security certificates so you can validate that your device meets all the current enterprise grade security standards. So that'd be number one. And also number two to think about is, do providers have wireless intrusion detection systems in place? Are they looking at people to keep the bad actors out of their network? So there's the connectivity security side, but there's also the enterprise intrusion side that I think is a growing marketplace as well.
Bob asked a great question. Is wireless getting crowded in hospitals? And I would say yes and no.
I would say yes and no. I mean, I think if you look at the ecosystem, 2.4 gigahertz is definitely getting crowded. So there's a move to move VoIP to 5 gigahertz. But there's two pieces to this. There's the network side, and then there's the RF pathway. So from the network side, most medical devices do not use a lot of bandwidth. So with modern networking division, subnetting, VLANing, trunk VLANs, if you appropriately set up your network for the network trafficking side of things, I don't think it's a big deal. On the provision on the RF side, I think there's a move to move more of the critical type stuff like VoIP to 5 gigahertz. There's more available channels. There's less multipath, and then moving off away from the 2.4. So again, it's proper modern day networking design. And if you look at the wireless LAN infrastructure providers, they're not static. They're constantly moving forward. IEEE standards are constantly moving forward on security, quality of service, roaming enhancements. So while the environment is very dense and there's a lot of devices, I think we have a tendency to think that before Wi-Fi, that I got into argument that Wi-Fi was never going to be safe for medical devices, and that WMTS was the only safe, quote, technology out there. But if you look at the billions of dollars being spent in the Wi-Fi space, all those issues regarding security, quality of service, roaming, they're all being addressed and have been addressed.
Yeah, I think particularly people from a medical device perspective, whether they're on the provider side or the vendor side, think back to the good old days of WMTS when you could just, design an antenna system, stick it in the ceiling, and put all your splitters and things in the wiring closets, and you're pretty much done. And the maintenance and changes for that network were very minimal over time.
Well,
Uh,
I had an unfortunate fortune. Right now, I've been in the wireless space actually 30 years. So I actually had the opportunity to design UHF antenna systems
yep.
possible in the United States. And I've had issues where I've had dropout continually and have had to go in and troubleshoot it and not being able to use enterprise tools to troubleshoot it and things like ballast and lights causing EMI being pulled back in. So the reality is WMTS is 30 to 40-year-old technology. It's the basic coaxial tables, antenna systems with splitters and amplifiers and power and couplers, and it's all hand done. So I would much rather deal with something that has enterprise grade tools such as Wi-Fi, and the companies are investing billions of dollars in it and it's moving forward versus using basically CATV infrastructure that was, 30, 40 years old.
Right, right, right. No, I agree that we don't want to go back to WMTS, but some people sort of think about how easy it was back then, and it certainly wasn't without its problems with dropout and interference and things. But the the requirements for the network and how you manage the network with Wi-Fi and other digital technologies is a lot different than it was, 30, 40 years ago.
Right.
And then that's not going to change other than those networks will get smarter, they'll get more automated, and more sophisticated and more reliable as we go forward. But there's been a fundamental shift for medical device folks, again, on both the manufacturer and the provider side, in that medical devices traditionally were very much a homogeneous environment. It was the embedded system device was a black box, and what was inside that black box was controlled completely by the manufacturer. And they could do whatever they want, implement their design however they wanted. As we get further into a world where medical devices are really information appliances on an enterprise network, um, there's a whole shift in mindset and organizational capabilities for both the provider and the manufacturer that really sort of form an underlying theme here for this whole discussion.
I mean, I worked with a, a company that made devices for the EMS that shock patients. Probably know what they're called, defibrillators. But here's this typical unique environment. So the ambulance goes out and they pick up they find the patient. Now you have that product which is now communicating via LTE. It's there on it's creating its own little Wi-Fi network around the ambulance, connecting itself to other devices, and then it's uploading that information, EKG and other data, real time via
Mhm.
4G to the cloud, going back to the EMR, so the EMR has that information right then and there. And then when the ambulance backs up, and then it shifts from LTE to wireless LAN, and instead of handing the nurse a bunch of paper, it dumps all the information that directly goes in electronic medical record. So I think you're going to see a crossover of multi-factor communication technologies communicating on the fly for different purposes.
Mhm. Even more fun. So, if there are any more, are there any more questions from the attendees? If not, we're going to. We've got time for some, but if not, we're going to wrap things up here a whole 5 minutes early. Um, so, David, I want to thank you for taking the time to share your expertise with the group, and I want to thank the participants for taking their time to join us. If you have any follow-up questions, you can send those to David or myself. And when the recording from this is done, we will update that into the blog post that announced this interview. So you'll be able to go click a link there and view the interview retrospectively, or if you've got peers that didn't get a chance to see it. So
Thank you for putting all this together. Thank you.
oh,
This
my pleasure.
wouldn't have happened without you.
Thank you. All right, well, that's it, everybody. Have a good day, and we'll talk to you later.
Thanks.